This is the video which accompanies Zephyr Team 2's Test Report 10, which presents the Communication and Telemetry Unit testing. This test was performed to verify Requirement 3, which requires a wireless data link between the blimp and the ground control station, to verify Requirement 25, which requires a wireless range which covers the search area, and works towards Requirements 14 to 17, which cover code-related requirements that need the hardware to be verified. The hardware components used for this test were an Arduino Uno, two XB Pro 60mW wireless modules, an XB Explorer USB board, an XB Arduino shield, a computer, a 9V battery and its associated cable. The next step is the assembly of the hardware. This graphic represents the basic architecture of the communication and telemetry subsystem. The left half represents the computer and its XB, using the XB Explorer board as the interface between the two. This will be known as the fixed segment. Its hardware looks like this. The right half represents the Arduino and its XB, using the XB shield as the interface between the two. This will be known as the portable segment. Its hardware looks like this. Once assembled, the system requires some basic configuration. This video will not cover these items as they are more easily outlined in the test report. The test also requires installation of Python and the PySerial library. The test software running on the Arduino is a very basic program which runs a continuous loop of checking for received serial data. If it does receive a serial packet, it simply sends it back. The test software running on the computer was written in Python with help from the ground control lead. It sends packets at a predetermined rate containing a timestamp. In parallel, it runs another thread which receives the bounce back packets and compares the time enclosed with the current time. It then saves all of these results to a CSV file. I'll run a demo now. This demonstration will show the use of software as well as what happens on the hardware when the serial connection is used. We will use a fake scenario with a range of 10 meters in an outside setting. This test will comprise of 10 packets. Now that the test is running, notice the LEDs on the boards on the right flash to indicate the transmission of data. Upon completion of the 10 packets, the program writes the data to a CSV file which we will now have a look at. As you can see, the CSV file contains the time taken for the packet to be sent and received. It also checks for any dropped packets and averages the time taken for the return of the packets during the entire run. The software was used for two subtests. The first was outdoor, which tests the maximum reliable range of the XBs. We plan to use the data gathered to compare with the second indoor test data. The outdoor test was run on a straight long road. The fixed segment was placed on one end of the road, at the left end of this map, and the portable segment was moved along the road to the marks indicated. At each mark, a test run was performed. The second test was an indoor test. It was used to check that the wireless environment didn't degrade the signal quality and that the communication subsystem would work for the required time of 20 minutes. It was performed in 0314 at Gardens Point, which is where the acceptance testing will be run. The test was run for 20 minutes. During this time, the fixed segment was in one corner of the room, and the portable segment was moved throughout the room. This was to verify that there were no areas in the room with wireless signals which may degrade our signal. When we reviewed the data, we found we could reliably achieve 200 meters of range from the XBs. It's also interesting to note that as the range increases, the ping time remains reasonably constant. The main thing we notice is that as the range is exceeded, some packets begin to be lost. As this 200-meter range is far greater than the search area requires, we have verified requirement 25. We have also verified our wireless data link, which verifies requirement 3. Our data showed that during the indoor test we had no packet loss at any time. This means that there were no adverse environmental effects and that the system can run for at least 20 minutes. This concludes test report 10.